What I want to do now is just define what we mean when we say polynomials. Now, first of all, here's what you need to remember. You've been working with polynomials since you've been working with numbers. Back when you learned to count, 1, 2, 3, 4, you were dealing with polynomials because the number 1, the number 2, 3, those are polynomials. When you add it, 2 plus 3, so that's 5. That's adding polynomials. 2 times 3 is 6. You were multiplying polynomials. So the mathematics that you've done for most of your life has been dealing with polynomials. So these are examples of polynomials. You have algebraic expressions, you have just numbers, irrational number, a fraction, a decimal, 2x. These are all examples of polynomials. And in fact, all of these can be written this way. So this is just the general formula that we use to say, okay, this is a polynomial. But we say this, n, the exponent of the variables has to be a whole number. And notice that's the way it is for all of these. Now, pi has not even got a variable with it. It's just a constant. And it would be like if all these terms up here were 0 and just the a naught, the a sub 0 at the end, the constant. So this would be like f of x equals pi, okay? So polynomials, pretty simple. Now, it might help to see, well, what is not a polynomial? So these are not polynomials. See, 2 to the x, that's an exponential expression there. Sin x, not a polynomial. 1 over x, cube root of x to the negative 2, x to the 2/3. These are examples of things that are not polynomials. And what makes them not polynomials is you can't write them this way. You can't write them this way. They cannot be expressed this way where n is a whole number. Okay? So, now, and here you've noticed that you've got 2/3. That's not a whole number. So now, here's what we have. We have a polynomial, and I want to define some parts of the polynomial. We can talk about the degree of a polynomial. The degree of the polynomial is when you look at the variables and you find the one with the highest power. So you look at all these terms and you find the term with the variable with the highest power. In this case, this would be a 5th degree polynomial. Okay, so that's one of the things that we want to keep in mind. Now, we also talk about the leading coefficient. The leading coefficient is the coefficient that's in front of that variable with the highest power. So in this case, x to the 5th, that's the variable with the highest power. The coefficient attached to it in front is 3. So the leading coefficient here is 3. Now, in general, we could have a polynomial that looks like this. This is the general way to write a polynomial. We have the degree n, this is an nth degree polynomial, and the leading coefficient here is a sub n. So there's not a lot to, when we talk about polynomials, there's not a lot you have to remember, except just remember, if you see something with a variable raised to a non-whole number power, then that's not going to be a polynomial. So sometimes thinking about what a polynomial is not is more helpful than thinking about what it is. If you can write the expression this way, where n is a whole number, then you're dealing with a polynomial.